Hi, this is Buono. Today I'd like to talk about voltage and ground. Up to last time, we looked at the amount of electricity flowing through parts, current. Today we move into another important quantity that sits alongside it, voltage. What voltage is and how it differs from current, which looks similar but is actually a completely different thing. And we'll also get the meaning of the reference point you need when reading each point's potential as a number, the ground symbol you often see in schematics. By the time this video ends, you will be able to explain in your own words that voltage is the difference between 2 points and that ground is the point chosen as the 0-volt reference. There's no hard math today either. Let's look at it one step at a time. Please watch to the end. First, let's start with what voltage is. Voltage, in a word, is the difference between 2 points inside a circuit. It's often explained with the image of a force that pushes electricity. The bigger this force, the more vigorously it tries to send the electricity out. Think of it that way. But keep in a corner of your mind that this is just an image, not literally the force that moves objects. The most important thing here is that voltage isn't decided by 1 point alone. You always pick 2 points and measure it as the difference. As an analogy, it's just like height. Think of the second and first floors of a building. How much height difference there is from the second floor down to the first floor is what voltage corresponds to. A place's height itself corresponds to potential, and the height difference of 2 places is voltage. The bigger the height difference, the stronger the momentum when you roll a ball. Picture the size of that difference as the size of the force that pushes electricity. The unit of voltage is the volt. For example, a wall outlet is roughly 100 to 230 volts depending on the country. A dry cell battery is 1.5 volts and so on. Next, this is the key point of the chapter. Let's make the difference between current and voltage clear. The names are similar, and at first it's very easy to confuse them. Current, as we learned last time, was the amount of electricity that flows through a part. Its unit is the ampere. Voltage, on the other hand, is the difference applied across a part's two ends. Its unit is the volt. In other words, current is something that flows. Voltage is something that is applied. This is where they're completely different. Here too, thinking with water makes it clear. Current is the amount of water actually flowing through the pipe. Voltage, by contrast, is the difference in the water surface height of 2 places, that is, the level difference. The relationship is that water flows precisely because there's a level difference, and the amount of water flowing and the height difference are completely separate quantities. Voltage is applied. Current flows. Remember it with this one phrase and you'll never confuse them again from here on. Next is the idea of a reference. As I just said, voltage was the difference of 2 points. So as long as you pick 2 points, you can say the difference of these 2 points is so many volts without deciding a reference. But the moment you try to state the value of a single point, how many volts is this one point, you're suddenly stuck. Because that in the end can also only be stated as the difference compared to somewhere. Without deciding the thing to compare against, the reference, a single point's value isn't determined. This single point value, the electrical height measured from the reference, is the potential I mentioned earlier. This too is just like height. How many centimeters is the height difference between person A and person B can be stated without a reference. But when you say how many meters is this mountain, you can't state it without deciding where height 0 is. In Japan, the reference is the average surface of the sea level 0 meters. For example, Mount Fuji's 3,776 meters is also a difference measured from this sea level of 0 meters. Potential is the same. To state one point's value, you need a reference of make this 0 volts. And here's where today's other star comes in. Ground. The point in a circuit you decide as let's make this the 0-volt reference is called the ground, often abbreviated GND. In a schematic, you attach the dedicated ground symbol to this point to show this is the reference. In terms of the height story from before, The ground is like a sea level 0-meter reference plane decided inside the circuit. You plant a flag at one point saying, this is 0 volts, then you can read every other point's potential as the height from that flag. The important thing is that the ground is something the designer chooses and decides. The 0-volt reference is a convention people decide for each circuit. In many circuits, a convenient point like the minus side of the battery is chosen as the ground. That is the 0-volt reference. Alright, let's decide a reference and actually read each point's potential. For example, consider a 1.5-volt dry cell battery. If we decide the point on the minus side as the ground, that is 0 volts, then the point on the plus side reads as 1.5 volts higher than that, plus 1.5 volts. Now we can state the 2 points potentials clearly in numbers. Now let's change the reference. Opposite to before, let's decide the point on the plus side as 0 volts. Then this time the point on the minus side is 1.5 volts lower than that, so it becomes minus 1.5 volts. Here something interesting is happening. Depending on which side we chose as the reference, each point's number did indeed change. Plus 1.5 volts in one case, minus 1.5 volts in the other. But what about the difference across the battery's two ends? In both cases it stays exactly 1.5 volts. It hasn't changed. This is a very important point. When you re-choose only the reference of which point to call 0 volts, with the wiring left as is, the only thing that changes is the numbers of each point's potential. The difference between the 2 points, the voltage applied across the part itself, doesn't change no matter where you take the reference. So think of it this way. Potential is a relative thing that changes depending on the reference, and the potential difference is determined regardless of the reference. Here's a field note for you. The ground that appears in a schematic, the 0-volt reference, is after all just a marker saying, let's make this the reference. In fact, this is a different thing from Earth, connecting to the actual Earth, the soil, what in Japanese we call setchi. The symbols are used distinctly too. What this means is that the ground isn't necessarily connected to the actual ground. So whether a metal part you can touch is safe is judged not by the name ground, but by is it really connected to Earth and does the protection mechanism work? For example, think of the metal frame of a device that isn't connected to the ground. Even if that's the reference inside the circuit, it isn't necessarily at the same potential as the actual ground. If, due to a fault, that frame ends up at a dangerous potential, and your body becomes the path connecting the frame and the ground, electricity could flow through your body and you could get a shock. To lower this risk of shock, there's a measure called earthing, what's commonly called the earth, connecting a device's metal parts to the ground by a prescribed method. But earthing alone doesn't prevent everything, and we won't go into its specific mechanism today. For today, keep in mind this one point. The ground, the circuit's reference, and the earth that connects to the ground are different things. The more of a pro you are, the more you check these two separately. Now, a quick check to test how well it landed. This time too, 3 questions you'll trip on unless you really get it. Take a moment to think. Question 1. Fill in the blank. What is applied across a part's two ends is blank. Which goes in current or voltage? Question 2. The ground point, the GND, that appears in a schematic is necessarily connected to the ground, that is the earth. Is that true or false? Question 3. With the battery left as is, we changed only the reference of which point to make 0 volts. Which one changes? 1. Each point's potential, that is, the numbers. 2. The voltage between the 2 points, that is, the difference. Have you settled on your answers? Let's check them on the next page. Alright, let's check the answers. Question 1's answer is voltage. What's applied across a part's two ends is voltage. What flows through a part is current. Remember them as a set. Applied is voltage, flows is current. Question 2's answer is false. The ground was the point chosen as the 0-volt reference inside the circuit. It isn't necessarily connected to the actual earth. It was a different thing from earthing, the earth that connects to the soil. Question 3's answer is 1. The numbers of each point's potential. When you re-choose the reference, each point's number changes, plus 1.5 volts becoming 0 volts, and so on. But the difference across the battery's two ends stays 1.5 volts in both cases. The numbers change, the difference doesn't. How many did you get? Go back over any you missed. So today we've talked about voltage and ground. First, the voltage was the difference between 2 points, the image of a force pushing electricity. And it was a different thing from the current that flows through parts. Voltage is applied across the two ends. Current flows through. Because voltage is a difference, you can state it without a reference as long as you pick 2 points. But the moment you try to state a potential, how many volts is this one point? You need a thing to compare against that is a reference. That's exactly why, in a circuit, you decide one point as the reference of make this 0 volts. That was the ground. Once you decide the ground, you can read each point's potential in numbers as the height from there. And when you re-choose only the reference without changing the wiring, the numbers of each point change, but the difference between 2 points doesn't. This was the biggest knack. Looking at it this way, today's story connects into one thread. Voltage is the difference of 2 points. To read one point's potential, you need a reference, and that reference is the ground. Keep in a corner of your mind the sense that potential and the reference are inseparable. That's all for today. Thanks for watching.